This is chapter 4, section 1. Now we're going to do probability distributions. So in the past we did distributions of data, right? So we did frequency distributions and all that. But the issue is every one of the data values that, didn't have a different probability of happening. So probability distributions, all the data has different probabilities of actually happening. Okay. So you need a random variable essentially. So we had variables in the past. We talked about extraneous variables and all that, but random variables happen by chance, right? So we measured, miles per gallon and nicotine levels and number of chocolate chips and IQ and like that. Those weren't random, right? We just collected data and put them in variables. That was it, and calculated variables. Now each one happens by chance. And they are either discrete or continuous, just like they were before, and we'll do examples of both throughout these next chapters. So basically, if it's discrete, it's countable, right, or finite, or it's not countable on a continuous scale. Okay. Okay. So there are basically three rules that need to happen. So one, the variable has to be a random variable. That makes sense, right? Because that's the whole topic basically of the chapter. The sum of all the probabilities must be 1, and all the individual properties must be between 0 and 1, right? So basic rules of probability plus the random part. So those three together give you a probability distribution essentially. As to how we represent that can be a few different ways, whether it's a table or some kind of graph, which we're going to use probability histograms. So it's the same thing we did in the past as far as histograms, except now the y-axis is probability. So let's say we have a problem here where students are monitored to see how, there we go, how many days a week they do homework, and so you do a probability experiment. You find 8% of them do 3 days, 2 days is 15%, 1 day is 4%, and no days is 1%. Suppose a week is randomly selected, right? So you're going to create a probability distribution table, or otherwise known as a PDF table, right? So X will be the number of days, right? Of days. Okay. Which will be 0, 1, 2, or 3 in this particular one, right? So we have our probability of X, because X is number of days, right? Probability of X. Okay, so we have 1%, we have 4%, we have the 15%, and we have, what is it, 80%? 80%? 80%. Okay, again, I'm writing its probabilities, not percent. And what you notice is adds up to 1. Right? So three things that need to be true is all the individuals are between 0 and 1, right? Correct? Between 0 and 1, probability-wise, right? Inclusively. The total is 1, and the variable is random, right? So that means this is a proper probability distribution, right? So let's make this a little bit neater and write this out, right? So make a nice, neat table, correct, right there. So all the probabilities between 0 and 1, they add up to 1, and the values are random by chance. Thus, this is a probability distribution. Okay, so let's do an actual one from scratch here. So let's say we have 2 4-sided dice that we're rolling. So obviously that is random because you can't control the dice unless some magic, I guess, or they're loaded dice. So the sum of 2 4-sided dice would be the random variable here, right? Okay, so we need a sample space. Right, so the sample space would essentially be a bunch of paired, right? Because you get a 1 and a 1 as your first pair, correct? And you can get a 1 and a 2, right? All the way to the last one, dot dot dot, which would be a 4 and a 4, correct? Okay. Because, there's 2 dice, they're each 4-sided, so you get a 1 to a 1 all the way to a 4 and a 4, correct? Any combination in between. So that should give us 16 different paired sample spaces, correct? Okay, so therefore, what's the lowest sum we can get? Well, the lowest sum I can get is a 2, one of the 1 and a 1, and the highest one I can get is an 8. Okay. So what does that mean? The lowest sum I can get is a 2, 3, 4, 5, 6, 7, and 8. That's all I can get. Okay, so if I look at my sample space here, let's just make this a little bit smaller, right? There is one way to get a 2, So 1 out of 16, right, because this is probability. There's one way to get an 8, right? 3 is 1 and 2 and 2 and 1. So there's two ways to get that, correct? 7 is 3 and 4 and 4 and 3. So there's two of those, right? Why did I write it? It's 16. I think it's because it's the number 8. That's what I was trying to get, but it's still 1 out of 16 possibilities. 4, I can do 1 and 3, 3 and 1, 2 and 2, correct? So that's 3 out of 16. 6, that'd be 4 and 2, 2 and 4, or 3 and 3. That's 3 out of 16, correct? And the last 1, 2, 3, 4 are all going to give me 5, correct? Okay, so there's my probabilities, which all are out of 16ths, right? Do not simplify fractions, right? Because essentially we want to add those later on, right? So, are my two things true? Well, three things. This is a random variable? Yes, obviously this is a random variable, so that works, right? Do they add up to 1? Yes, because if I add all these up, what do I get? I get 16 out of 16, don't I? Are all of these between 0 and 1? Yes, they're all between 0 and 1 inclusively, right? Okay, so let's draw a probability histogram of this particular data, right? So if I draw this, all right, I'm just going to do an axis, right? So this is X, this is the sum of the dice, right? Okay, and you only need 2, 3, 4, 5, 6, 7, and 8, right? And on the side, you're going to have probability, right? So probability goes over here. Okay, and you can do it in 16ths, right? So you have 1/16, right? 2/16, correct? 3/16, and this only goes to 4/16, right? Okay, so the first one is 1/16, 3 is 2/16, right? 4 is 3/16, 5 is 4/16. Ooh, this is terrible art, right? So I think yeah. All right, good enough. We got to put a title here, which is the sum of two four-sided dice, correct? Okay, I do this ahead of time so we can actually have this, right? So that's a little bit of a hand drawing there with pen, so it's quite a bit better. Okay, all right. Oop. What's going on there? There we go. Okay, we can size that up a little bit. All right, so you only need to make the ones in the bottom that actually exist. Don't start at 0 or 1 if it doesn't have it, and you can go by 16ths on the side. You don't need to convert to decimal; that's not necessary. Plus, if it's like sevenths or something like that, it's not going to work out rationally. So it's better just to keep them as fractions, whatever the case may be. All right. So type, title, right? Label the axes. Make sure these are in fractions for the most part, unless they somehow work out nicely, right? And you can shade these in if you want to, but that's not incredibly necessary. Okay, you get a nice symmetrical probability distribution. All right, that's the end of section 1.